Hi everyone and welcome to our movie. I'm Amanda Forsberg.
I'm Gonzalo Blasco.
And I'm Martin Alto, and we are going to talk about flanking transmission in concrete walls and floor.
The purpose of the project is to calculate the sound flanking transmission from room 1 to room 2 that is below. The floor and the walls are made of concrete, and the dimensions of the room are 6 meters wide by 3 meters deep.
We will calculate the total sound reduction between room 1 and room 2 for varying thicknesses of the walls and floor. Then we will compare this value to a limit value given by the Swedish standard.
For the calculations, we will start by using the thickness 150 millimeters for the walls and then 200 millimeters. For each values of the walls, we will use 3 different values for the floor. It's 150 millimeters, 200 millimeters and 250 millimeters.
First, we have to find the limit value for sound isolation that we want to fulfill. After looking up several standards, we found a value for airborne sound isolation giving us 53 dB for sound class C. Sound class C is the lowest allowed sound class in Sweden. In order to compare this value with our calculations, we'll have to use this formula, where RW is the reduction index for direct and flanking transmission and C50 3150 is the correction term used to account for subjective perception of lowest frequencies. Let's start calculating RW, the sound reduction index.
This is the equation for RW, and in order to calculate this value, we have to take RDD, RFFF, RFD and RDF in consideration. And this different R is the path that the sound can take through the walls and floor. And the first one is direct. Then we have flanking, and flanking direct, and at least direct flanking.
For calculating each one of the different flanking paths, we will use this formula, where Ri and Rj refers to the kind of sound transmission depending whether they are flanking or direct. Kaj refers to the kind of junction and is called vibration reduction index. SS is the surface of the floor, L0 is always 1 meter, and Lij is the length of the junction. We will start calculating Ri and Rj for each kind of thickness of concrete.
For the project, we were given data from laboratory measurements. The data showed the sound reduction at different frequencies for different thicknesses of concrete. We used the data and the reference curve for airborne sound isolation to calculate an equivalent sound reduction index. It is the same method as in the formal summary. The values are then used here.
Now we are going to calculate the vibration reduction index, this one. To do this, we use a T-junction like this, and the calculations we did according to the Swedish standard.
We now have everything we need to calculate Rij, which gives us Rw, and all that is left is to calculate the correction term. To calculate the correction term, we use this equation from the standard. This is done for each thickness. Ri is the sound reduction from data, and Li are values from the standard. The measured data started at 100 Hz, so first we have to estimate values for 50, 63 and 80 Hz, like this. Req is the equivalent sound reduction index that we calculated earlier.
We have now calculated RW and the correction term. Let's see what the results will be.
We see that all sound reduction values for each combination of wall and floor thickness are above the limit value. 53 decibels is the lowest allowed sound reduction for sound class C. If we instead look at sound class B, we have the lowest allowed limit of 57 decibels. This requirement is met by only two of the result values. For wall thickness 150 mm combined with floor thickness 250 mm and wall thickness 200 mm and floor 250. A separate task in the project was to calculate the radiation factor. The radiation factor describes the efficiency of a surface as a sound radiator. This is the definition of the radiation factor. For calculation, however, we use the method provided by the standard. It's very complicated. Here are the results. The purple line describes thickness of 150 mm, the blue 200 mm and the green 250 mm. The thicker the floor, the lower the radiation factor.
So, in conclusion, all combinations of wall and floor thicknesses meet the lowest requirement of sound class C.
For higher sound classes though, only the thickest floor meet the requirements. To improve the sound reduction, several measurements could be taken. For instance, a floating floor or a resilient wall layer could be installed to prevent vibrations to spread between two rooms.
And maybe the most importantly, the design of the junction could be done differently. If the walls were separating instead of continuous, sound waves would less easily spread between the two rooms.
I've heard of the secret chord that David played and it pleased the Lord. But you don't really care for music, do ya? But it goes like this: the fourth, the fifth, the minor fall and a major lift. The baffled king composing hallelujah.